Thanks, Roberto. When I heard 2 months ago from Harvey Mehesh, our local representative for Fiesmann, that there will be a biomass conference here in Nipissing, I expected a very small event, actually. And I'm actually really thrilled that it turned out such a great event and that there is that much opportunity for biomass here in Northern Ontario. So thank you, guys. I'm here to talk a little bit about biomass boilers and about the engineering perspective of biomass boilers. As Roberto said, I'm representing Fiesmann Manufacturing. We produce all sorts of heating equipment, fossil fuel equipment, and now biomass equipment as well. We do have solar panels as well. So what does biomass heating mean? It's pretty much a renaissance of the first energy known to man. So pretty much what we do, we used to have those bonfires, and now it's just a little bit more sophisticated. I mean, that implies a lot, though. A few facts about biomass. Why biomass? We heard a lot of that already in the last 2 days, but yeah, wood is considered a CO2 neutral source of energy. Wood is a sustainable source of energy and helps to maintain independence, and more importantly, it helps us to maintain a local independence. Yeah, wood is a local staple and can be harvested with a very small amount of energy, especially in a region like Nipissing or North Ontario where we have that much biomass. Wood as a fuel contributes to our regional economy. That is always something that is very important, and it creates and saves jobs. Modern wood heating systems, if properly operated and maintained, are very safe, very clean, and meet similar emissions than fossil fuel equipment. In times of soaring energy prices, I mean, right now we don't have the soaring energy prices, but we all know that this is only a matter of time when fossil fuels will rise in price again. Burning wood is economically highly competitive, and it will be in future. A little fact box, those are mainly facts from Europe. Just to give you an idea what's happening. In Germany, there are more than 100,000 pellet boilers in the institutional, residential, and commercial market. Roughly 350 pellet mills produce more than 6 million tons of wood pellets. That means biomass is actually getting a commodity more and more. Fiesmann has got 30 years of biomass experience, and Fiesmann now produces more than 500 boilers for commercial, institution, and industrial sector, and thousands of residential boilers. So you can kind of see this is not a onesie or twosie thing. It actually is an industry, and for North America, it's in its infancy, and it's good to see that Northern Ontario is taking a lead here and going the extra mile in order to create an opportunity for the region. In Central Europe, biomass boilers have already a higher market share than oil boilers. And wood fuel accounts for more than 25% of the overall heating energy in Austria. That kind of tells you what the potential is. It's insane. Some of you might have asked themselves, how renewable are wood fuels really? I just want to give you a little idea. 1 gallon, or actually let's put it in liters since we're in Canada, 1 liter of heating oil equals roughly 5 pounds of wood. So a single home, depending obviously where it's located in the States, you won't need that much in Florida, but up here you probably need 4,000 liters of fuel oil to heat your home. This would be an equal of roughly 12 to 16 tons, depending on the wood of wood chips. The productivity of a forest, mixed hard and softwood, is around 1.5 to 2.5 tons per year. actually just natural regrowth. So that means that 6 to 9 acres of forest can sustainably heat a home. That gives you a little bit of an idea how many homes that can be sustainably heated in Ontario. It's a lot. But what are the factors to be successful in that market and to have an environmentally and economically successful operation? One, the right choice of fuel. That is a central point. Second, the right choice of boiler and auxiliary equipment. And third, last but not least, the correct embedment of the biomass boiler into the hydronic system. I'm gonna explore a little bit about the fuels. I can only skim the topic since we got 15 minutes allotted for talking about that, so you can talk a day about wood fuels, obviously. There's different fuels. First of all, forest wood and plantation wood, pretty much wood chips from branches, trunks, untreated and chopped. Then what we see more and more is wood pellets. They're made of untreated wood with a limited bark content to keep the mineral content down and keep the ash content very low. There's bark, tree cuttings from roadside trees, remnants from derived timber. That's pretty much the low ones are waste products from different wood industries. As I said, the fuel is a very central point in a biomass heating system because the wood determines a lot about the biomass system. First of all, it determines the technical specification of the combustion chamber and also about of the feeding system. It also determines the specification and, more importantly, the size of the storage facilities. Those are major points, especially how much the investment is going to be. If you're going to have a huge silo, it's going to be fairly expensive. It also determines the overall efficiency, the maintenance effort, and also what sort of emissions we are going to face, and consequently what emission treatment is going to be needed. And it also determines the life expectancy of the boilers and the conveyance equipment associated with that. Just a little overview so you get a little bit of a feel about wood fuels. I don't know if you see that in the back. We've got wood pellets here. They have got a water content of around 5%, and the thermal value is roughly 8,000 BTU per pound. If you compare that to heating oil is at around 18,000. So pretty much you could say that wood pellets have got half the heat value per pound. If you take wood chips have got substantially higher moisture content. Since we all know that water doesn't exactly burn, the BTU per pounds go down, the moister the fuel gets. A forest wood chip with 30% has got 5,500 BTUs per pound roughly, and wood chips wet drop dramatically. So that has got some implications how far you can haul wood chips in order to make it economically competitive. Because you don't want to truck 50% of your truckload if 50% of your truckload is water, and it's not economical to go long distances with that. That means the further away you're from the forests, the more quality fuels will be the choice. You can see there's a tremendous variety in wood fuels with different chemical specification and therefore different qualities. The quality of fuel is a very central factor financially and environmentally. With fuel oil, we've got standards. With natural gas, we've got standards. Wood fuels, they're all over the place, and we got to make sure that we're going to have quality wood fuels. About system design, I want to skim that topic a little bit as well, since it's a major part of my presentation. obviously. Lawrence talked a little bit about the requirements that we have here in North America. Boilers need to be CSA approved according to CSA 366.1. They need to bear the ASME stamp. You can clearly see if a pressure vessel has the H stamp because it has to be visible on the boiler itself. Pressure vessel designs need to be registered with provincial pressure vessel jurisdictions, just as Lawrence said. It's a little bit of a painful process, but once you're through, you can comfortably sell your boilers all across Canada. In order to start the design of a biomass boiler, you need to know what kind of fuel you're going to use, and that kind of determines what kind of storage facilities you will have. Especially with wood chips, it's not that with fuel oil we usually size our tanks that you have got fuel oil for the whole winter. With wood chips, that's not going to happen. It's not economical. A good sized bunker holds between 7 and 14 days of wood chips. Somebody might say, well, that means that the truck has to come every 14 days. That is true. But if you design the bunker so that they can hold multiple of truckloads, it doesn't matter, because if you would only fill it once a year, you would have 20 trucks coming by on one day. Now you have 20 trucks coming by a bunch of times during the year, so it doesn't really make a difference. But the investment is substantially lower. Yeah, bigger bunkers are not economical and reduce the paybacks, therefore. There's different types of bunkers. Especially in Europe, a lot of the bunkers are subterranean. Here in North America, you see above ground bunkers as well. Subterranean bunkers are much easier to fill up, obviously, because you just dump the fuel into them. Above ground bunkers are a little bit harder to fill, and it might be, like for bigger operations, a wheel loader might be necessary. So you might want to look into the subterranean option. Storage of wood pellets is a lot easier, since they flow a lot easier than wood chips. But of course the fuel is more expensive, so it's kind of a calculation whether you go with wood pellets or wood chips. There's different ways of extracting the wood chips out of the bunkers. What you see here is a spring-operated extraction system. As you can see, you fill it from above, and then there's arms attached to a disc that swipe the fuel onto an auger, and that extracts it then towards the boiler. That's for medium-sized systems, for smaller schools, community heating systems, for a community center, for example, not really for big operations. For bigger operations, we usually use a walking floor. What that is, there is a rack, there's one or multiple racks of wedges, iron wedges, or steel wedges actually, on the ground of a bunker, and they pretty much rake the fuel towards an auger and extract it again. You can see on the left-hand side how a truck dumps the fuel onto that mechanism. Here's a little drawing. You can see that there is multiple wedges in that bunker, and they pull the fuel slowly but surely towards that auger that extracts it and feeds the boiler. This is a picture how that looks like. The bunker obviously is on the left side, and you can see the hydraulic rods pulling the fuel into a trough, and from there it's going to be transported towards the boiler. Here you see the auger, and those are dimensioned lids. So if you pretty much open hydraulically, the truck backs up and dumps the wood chips into the bunker. That's what's happening right here. This extraction system I'm probably going to skip because it's more for the wood processing industry than for district heating. And pretty much there's an auger in a funnel and it augers it out. Pellet systems, what we see more and more here in North America is that we have bulk delivery with pellets. That was not really usually the case. In Canada and the US, most of the pellets have been delivered in bags. If you want to heat a hospital with wood pellets, obviously bagged wood pellets are no good. So they come in a big truck, pretty much like fuel oil, and they pump the wood pellets into a storage facility. Here you see a building that is equipped with a wood pellet silo. The wood pellet silo, as you can see, has got a little funnel, and the wood pellets pretty much slide onto an auger and get transported into the building. What you see here, that is a college, or a college in Maine, and it's a carbon zero college. So their goal was pretty much to offset all their carbon emissions that they make. And I mean, obviously you can't offset all of it, so you have to take measurements in order to absorb more carbon. But the wood pellet biomass plant was one of their measurements to reduce their carbon footprint. This boiler is located in BC, a very small community. It's a primary school. And pretty much what they did, they bought a fully containerized boiler. So pretty much the whole boiler room is in a shipping container. So all that the school board had to do is provide a concrete slab at the backside of the school. And we pretty much just dropped the container and the silo and hooked it up to the heating system. So that is a very easy way to adopt and to get a biomass boiler. And if you don't have the room, if you don't have a big mechanical room, we can help you out with that kind of solution. About the system design, I mean, you can design a biomass system in multiple ways. It can be the only mean of heating. Then we have got a monovalent system, so the biomass boiler covers the whole heating load and is pretty much the only source of heat. You can tie it up with a fossil fuel boiler, pretty much oil or gas boiler. The oil and gas boiler would cover the peak loads and would also probably cover the summer loads or some of the shoulder seasons. Or you can also use multiple biomass boilers. That helps with the modulation, and you've got redundancy. That means if one boiler would be theoretically down, you would have another one. We see that a lot in hospitals and institutions where there's never only one heat source. There's one boiler that covers the whole heat load and one that's pretty much sitting there in case of emergency. That happens also with fossil fuel boilers. Here you see a heat curve and how the whole heat demand can be covered by biomass. I want to actually just point out one little thing, because otherwise it's going to probably get too technical here. But if you size the biomass boiler only for 75% of the overall heat demand, and you topped it up with a gas boiler, for example, just to cover the peak loads and the summer loads, you can offset 97% of your heat can be created with biomass, but you downsized your boiler by a quarter of the heating load. That means that is a substantial saving right there. We also use accumulator tanks in our biomass systems. Why that is? I mean, if you ignite wood, it obviously takes a little longer than if you just light gas. So we've got a little bit of a delay. And once a pile of wood chips is burning, it's kind of hard to just switch that fire off. That's not really going to happen. So what we do, we have a hot water storage tank, and the biomass boiler feeds into that storage tank. So once the heat demand comes from the radiators, whatever you have, the boiler realizes a lot ahead of time that we have got a heat demand, because there is some energy buffered in that tank. And also when the biomass boiler shuts off, or is supposed to shut off, we can dump the remaining load of that pile that is still burning into the hot water storage tank. That means that we don't lose any of that valuable heat. So what does a storage tank do for us? It boosts heat availability, it covers brief peak demand requirements, absorbs excess heat when boiler shuts off for later use, and it also creates a clear separation between the boiler plant and the system. It allows an optimal connections for other means of heating, like solar or redundancy boilers. Once you have got that thing in place, the most expensive part of your solar plant would be already paid for. So you only have to buy the panels. The hot water storage tank is pretty much the most expensive part of your solar system, so it's kind of a natural fit. So as a conclusion, biomass boilers nowadays are very reliable, economically viable, and environmentally safe. The proper design of the system is obviously crucial and determines payback periods, reliability, and to some degree also the serviceability of the heating system. Viessmann is more than willing to really assist you in that task. The right choice of fuel is a very central role in a successful biomass heating plant. So you want to get the ducks in a row and have a steady fuel supply in a certain quality first before you actually start talking about a biomass system. Yeah, that is pretty much what I had for this conference. Thank you very much for your attention, and back to you, Roberto.